Okay guys, let's move on to the next question. Determine the forces acting in all the members of truss. So we have how many truss member here? 1, 2, 3, 4, 5. We have a 5 member. So I want you to know how to define the internal force, whether this is in tension or in compression. Before we start applying the equilibrium equations in each joint locations, this A is pin connected and this C is a roller, so there is only one support reaction, which is a CY, and there is AX. Sorry, this should be AY, this one is AX. Note that this entire truss is in equilibrium, then each location is in equilibrium, and we have only one external forces. This is 3 kilonewton, which is pulling right-hand directions. So we can find that CY, because how? When we apply the equilibrium equation, sigma moment at point A is equal to 0. So we know that 3 kilonewton create the clockwise rotation about the point A, so minus 3 kilonewton times what is the perpendicular distance, that is 2 meters. And this CY should create a counterclockwise rotation. That's why it will be cancelled out. So CY times the perpendicular distance in this case is 4 meters. So from this equation, we can find that CY is equal to 1.5 kilonewton. CY is 1.5 kilonewton. Since CY is a positive upward direction and the magnitude is 1.5, that means the direction of the AY must be downward, and the magnitude should be 1.5 kilonewton. And also, the support reaction at point A for the horizontal direction, it should be left-hand direction because of this 3 kilonewton, and the magnitude should be 3 kilonewton. So we all defined unknown support reactions. Now we jump into the solve the forces acting on each member. Let me pull out the keyboard. I guess there is some noisy sound when I pull the keyboard from the laptop. Sorry guys. Let's see. So we can redraw the diagram. It's okay to take the time, but I want you to draw the free body diagram first when you solve the problem. Oh, we have angle information. Okay, that's good. Okay, I think this one is also 30 degrees, and this one is also 45 degrees, which is a symmetry. So that's why I use the same angle here, and the dimension is here with 2 meters. Okay, that's pretty much it. I mean if you want to solve the problem easily, then which joint location we should start first? The answer is we have to choose the right joint location. The right location means the joint has a least number of unknown forces, which is easy to solve. So in this case, point B has 3 unknown, point D has 3 unknown, point C has 2 unknowns, and point A has 2 unknowns. So which one we should start first? Now let's choose point A. Okay, let's choose point A. Point A. Let me use another color. So for the x direction, so here we know 2 support reactions, and we know the direction of the reactions, but we don't know whether the member AB and AD are in compression or tensions. Okay, so let's assume that member AB is in compressions and AD is in tension. Okay, this is our assumption. So the Fx, there is minus force BA, because let's define the this is positive x, positive y. So the left hand direction means minus x axis. So minus FBA cosine 45. In this case, the angle here, this is 45. Okay, plus FAD cosine 30 minus, we have one support reaction that is the left hand direction, which is 3 kilonewton. Okay, this one is equal to 0. For the y-axis component, we have a minus FBA sine 45 plus sine 30 minus 1.5 is equal to 0. Okay, so from the first equations, we can say that FBA cosine 45 is equal to FAD cosine 30 minus 3, right? Since FBA sine 45, FBA cosine 45 are the same, so we can plug this to here. Okay, so that means minus FAD cosine 30 plus 3 plus AD sine 30. We have one equation and we have one unknown, which is AD, so it's solvable. FAD, in this case, we can find this is 4.098 kilonewton, and this is not a negative number, so our assumption was right. Force AD is in this is in tension. And since we find the force AD, we can plug this number to here, so we can directly find force BA is 0.776 kilonewton, and the sign is positive, which means the direction was right. Our assumption was the direction of the member is in member AB was compression. So this one is compression. Now we find two internal forces, member AB and AD. Now we can move on to joints B or C or D, because any joint has only two unknowns. Okay, so let's try. Let's try joint C. If you look at the joint C, we still have two unknowns. That is force FBC, force DC. These two are unknowns. So let's assume the direction is member BC. Probably this one is in compressions, and this one is maybe tensions. We don't know. We can figure out later. So for the x-axis, we know that force BC cosine 45 minus F DC cosine 30. This one is equal to 0. For the y-axis, minus FBC sine 45 plus FDC sine 30 plus 1.5, because we already know that there is a support reaction at point C. This one should be equal to so we have a two equation and two unknowns, so it's solvable. From the first equation, we can find that FBC cosine 45 is equal to FDC cosine 30. Since FBC cosine 45 and FBC sine 45 are the same, so we can plug this one into here. So minus F BC then we can find the FDC is equal to 4.098 kilonewton. And still we have a positive sign. That means our assumption is right. So force DC, member DC is in tension. Since we find FDC, then we can automatically determine FBC. FBC is 5.019 kilonewton, which is compression. So we know that we find 4 internal forces. Now we can find member BD. BD is just a piece of cake, because if you look at the point B, okay, this is B, we have only one unknown force, which is member BD. So we can apply only one equations, that is there is a little limited space, sigma Fy is equal to 0. So we already know there are two forces, member AB and BC are in compression, and the direction is positive upward. So what was the member BA? BA is 0.776. Okay, 0.776. And the positive upward. This should be cosine 45 or sine 45. Either way is fine. Let's put it the first cosine 45. And another one is member BC. BC is 5.019 cosine 45. Okay, there is only one unknown forces. I believe that one should be downward direction, which means it's a tangents. Okay, so minus FBD. This one should be equal to 0. So we can find the member BD F. Let me write down here. BD is equal to 4.098 kilonewton, and this one is in tension. Okay. So we find support to reaction first, based on what we have in the questions, and now we find all 5 internal forces here. Like I said, when you know how many forces are acting on each member, then you can decide which member should be thicker or thinner. We can decide it because this is very important. Why? Because all the material is a cost. Okay, so we want to minimize cost, but we also satisfy the right support to hold the weight. Okay, so knowing how many forces are affecting in each member is very important in terms of the saving material cost, as well as secure the stability. So here, if you want to work at the NASA, you may want to think about the structural design. Like this case is this is a simple truss case. So you know how to calculate all the forces are members in each members. So definitely this is interesting job positions after you graduate. Okay. So today we had 2 learning goals. We know how to define the simple truss, just adding 2 members and expanding a triangular shape. That is a simple truss. And the second goal was we already know how to determine the forces in each member, whether this is in tension or compressions. Today's lecture is very important. This is the first lecture we mentioned that there is a tension and compressions, and this is a simple truss and the method of joint. So I want you to clearly understand the questions, and there is a homework. I will assign the homework later. You will figure out the announcement through the blackboard. Okay. Hope you have a great day. Be safe.